So before we start, quick question. How many of you have seen the latest Venom movie? Hands up. Like 50% of the audience. Did you like it? Sorry, I can hear you. Did you like it? Awesome. So there may be some references in this talk to this movie, because I like it as well. All right. Hello, everyone. My name is Martin Hochel. I work as a principal software engineer at Embedded IT here in Prague. And I'm also Google developer expert for the web. You can follow me on Twitter. My Twitter handler is Martin_Hotel. My technical articles are published on medium.com. And you can follow me on GitHub, where I'm trying to publish open source libraries and help other people on the intranets. And last but not least, I'm also organizing the biggest JavaScript meetup here in Prague called NG Party. So definitely, if you're into JavaScript, check it out. Okay. So let's make things clear what is this talk not gonna be all about, right? We're gonna do some deep dive into React, into APIs of React. Everything is in the docs or at internet, and the same applies for TypeScript. Like, I'm not gonna explain all these principles, what it is and why we need it. Maybe just in short, React is a small library for writing user interfaces, and TypeScript is JavaScript with typed. What does it mean? Well, you have types in JavaScript because JavaScript is a dynamic language, and as we all know, we just need those types for better developer experience and so on and so forth. So what is this talk going to be all about? We're going to talk about patterns. And what kind of patterns? In particular, component patterns. Because React is just a bunch of components, right? It's the single atom. And of these atoms, we can build the whole ecosystem, which is called, in the end, our app, right? And this is how it looks like. These atoms are formed into a tree of components where we apply one-way data flow. What does it mean? Like, we cannot change some data in a child. We need to notify our parent. And parent needs to change the state and propagate the state down. So it's like top to bottom data flow in our components. So how are we going to showcase these patterns? Well, we're going to do live coding. Because live coding makes sense, especially in front of audience. So you're going to be my live debugger. Pretty expensive live debugger, if you ask me. But hopefully you're going to help me if I get stuck into something. So with that said, let's get started, right? So on the right, there is my editor. There is some code. On the left, there is a browser with a web server running where we're going to show like executable code, okay? And before we start, let's just talk about what is component in React. It's just a function that accepts some arguments. They are called props. And as a return, it gives us some view. And that's everything, like just pure component, pure function, if you say. And how does it look like? So let's code something. So we have here some function. Let's say I'm going to do a function component, which will return some div, just like that. And I'm going to define some props. And because we are in TypeScript, we need to define the type of those props. Let's say it's going to be greeting of type string and name of type string as well. And now we need to annotate those props, just like here. And now, what can I do? I can just emit a greeting, props, name, right? And now, if I execute this function, because as I said, it's just a function, right? Just greet, I'm calling greet with greeting. Let's say it's gonna be hello, and the name, GeeCON. And now I need to render it, just like you. And as you can see, there is the function. So really, React component is just a simple function that returns some view. We can define components also with class. So let's do that. And this component, this is a generic class. So we need to annotate the class with the props. And we cannot render just the markup, but we need to provide a render method, which returns the same stuff that we did before. So I'm just going to copy this. And now I need to use the structuring within TypeScript to get my props. So again, greeting, a name. And I can remove this. And this weird syntax is called JS6. And because we're using TypeScript, we have complete static analysis and IntelliSense within our templates and our code, of course. Now we don't see anything because it's a class, right? So you may be thinking, let's new the class up, but that doesn't work. And we need to be explicit because how React instantiates classes, and we need to use this create element. Then the first argument is greet, and then we have our functions, props. And now it's back on, right? If I change the values, I don't know, hello Martin, it's gonna reflect in the browser. And let's say I don't want to provide all the times the greeting. I can provide, it's called default props. So let's define default props in our class. So static default props. And it's gonna be like greeting, hello, hello, whatever. And now we need to type these props with those greetings. So one thing that we can do is mark this optional, but this isn't a very good pattern. Instead, we can encapsulate this static to some constant. And let's name the constant default props again. And now what I can do some type intersection and inference that is provided by TypeScript compiler. And just do type of default props. And now the type of props is again the same interface that I had before, but now the single source of truth is implementation rather than type system, which is great. And let's refactor this, format this. Okay, like that. And now when I will remove the greeting, there's gonna be just the hello, the name, but it's still gonna work, right? But in reality, you don't write code like this, and instead, you're leveraging JS6, where I can reference this class to be like greet with name. And that's it. As you can see, the type system knows that greeting is default prop, and it marks this type as optional, this question mark symbol. So that's very good experience and very easy way how to write components in React. All right. So next type of components that we have in React are so-called stateless and stateful. So stateless component is again just a function that accepts some arguments and renders some view. It's like pure function. So let's go back to code and let's write something more useful than just this greeting. And let's write some button component. So it's gonna be like this, and I'm gonna return button. And again, I need to provide some props. And to provide the props, I need to type those props in beforehand. So we need to go and use the children. And children is gonna be type React child. Next thing that we wanna do, we wanna provide some coloring functionalities for button. I'm just gonna copy here. And as you can see, I'm using string literals, not just pure string. That will constrain me to be only able to use these kind of tokens within my code, which we will see later on. And last but not least, I need to provide some callback. Let's name it onClick. And onClick is going to be some function that's going to return nothing. And it's going to accept an argument of type of event. And in our case, it's going to be mouse event. And let's annotate this, just like that. And again, I can use the structuring even here. So it's going to be color, children, and onClick. And as a button, I'm going to render the children. OnClick, I'm going to use or onClick, just passing down the properties. And last but not least, let me do some CSS stuff here. Like, let's say it's going to be class name, and we can use string interpolation, which is a JavaScript feature. And let's say that if color is going to be provided, let's mark it optional, right? If it's going to provide it, then I'm going to render button of type color like this. Otherwise, I'm not going to provide any type of CSS class names into our components. And now let's export this button because we're gonna use it later on. And I cannot type. And let's see if it works. So I'm gonna provide button, and I'm getting here some compile errors because I'm not complaining with the API defined by this button. So again, I need to provide children. What else? Color, that's optional, but let's say like primary. And on click, I'm gonna provide just some inline function that's gonna console log click. And here's the button, and if I click, it works. So that's fine, that's just functional component. So what about the stateful component? Well, stateful component is very similar to functional, but you need to define it by class. And what I mean by stateful, it has its own state. So internally, if this state changes, the component will be rendered and will handle that state for us. So let's define some counter component. Extends component, and again we need to define props. In our case, we don't want to use any props in this time, and it's going to be the state. State is going to be type of counter of type of number, and let's use this right here. So prop state, and now we need to render. And what do we need to render? It's going to be a div with some class name again. It's a row, border, I don't know. And let's use our buttons. So we'll have a button like this, and this is gonna be like thumbs up. Another one's gonna be like thumbs down. Great, and now I can provide the counter. In our case, it's just gonna be null. And the button is complaining again because I need to provide some onClick. So onClick, I will implement some handle increment. And here I'm gonna define onClick this handle decrement. And I didn't implement these methods, but I'm getting instead like compile errors. I will just change these props because I have a naming collision here. So this is going to be button props and button props, just like that. All right. And we need to define the state, and it's going to be our counter of type 0. Now what I can do right here, I can again do the structuring of this state and get the counter, and instead just 0, I'm going to use that counter. And let's implement those methods. Before, let me reformat this a bit. All right, so handle increment. It's going to be a function that's going to just set state internally with some updater. So the updater is a function that accepts a state, which is a previous state, and needs to return a new state. And because I'm using TypeScript, I have the whole IntelliSense of the allowed properties in that state, right? So that's great. And I'm going to just do counter the previous state incremented by 1. Again, if I do some typos, I get immediate errors thanks to the TypeScript. That's something is not okay. And I will do the same for the decrement. Except I'm gonna use minus. And let's see if it works. It doesn't work because I'm not rendering it. So let's remove this button and use a counter, just like that. Oh, it's back here. Boom, 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 boom. Perfect, that works. One small pro tip, like you don't want to do this, because now if I change the state with the refactoring, let's say it's going to be count, whatever. Okay, let's go back and count. It changes only here, but not in this type, right? So I need to do like this and manually refactor, and that's not very funny. And it's very error prone. So again, what I can use is to extract the state, initial state, outside the class, just like that. Then I can use, again, TypeScript to get a definition for me from the implementation. And here I can just reference initial state. And just fix this, count, count. And now if I will change this count to counter, everything was constantly changed without errors. So there are one more errors, like this and that. Great, so this is stateful component with the state, right? So let's say now I want to control this component from outside, right? Like some parent component wants to leverage some other functionality. So how can I do that? I can introduce this pattern called controlled and uncontrolled components. So we already implemented this counter, which is a controlled component, but I cannot, sorry, it's uncontrolled component, but I cannot control it from outside. So what I need to do, I need to implement some props behavior that's gonna be like source of truth by changing the state of this inside component, but in reality, the state is gonna be changed only outside the component. So let's implement that. And for this, I'm gonna just copy paste this. And let's go here. I'm just gonna paste this code. Switch to control uncontrolled. Right, I need to import a button that we implemented previously. It's right here. So, what I wanted to do from the terms of API, like here's my counter that works, right? But what I want to do is to have some counter, and I want to set the state from outside component. In our case, it's an example component, and have some onChange callback that's going to execute some handle change within my counter. So with that, let's implement the state in this component again. And also we need to implement handle change, which is gonna get this new count of type of number. And all it's gonna do is gonna set state to our new count. New count. And I'm gonna get an IntelliSense again because I need to provide the state here. I'll just check if that works. Perfect, that works. I'm gonna just reformat this a bit. Okay, I have some errors. What I need to do, I need to use destructuring for my parent state. So again, this dot state, not set state. Thank you very much. Count. Now that works, but still there are errors because we didn't implement the behavior to our counter yet. So let's do that right now. So our props gonna be like count, which is gonna be optional of type of number, and then some onChange, which is gonna be function, and it's gonna propagate the new count, and it's gonna return anything. So what I need to do right now? So handle inc. So if this props that count is gonna be present, all I want to do is call just this onChange without exposing or reusing internal behavior, and I need to increment this by 1 to mirror this functionality that was formerly provided by this component. Else, I want to call again this as before, but also after this I can use this callback, which is going to be called when the state really updated, and on here I can call again this onChange, and then this time it's gonna be with the new updated state of count. So, but this isn't very nice behavior or very nice code. So what I can do with this state, I can extract state to some getState function, and it's just gonna return new type of state. In our case, it needs to be count. And again, if it's going to be controlled component, count is going to be set. So I'm going to use that. Otherwise, I'm going to use internal state. So state count. And now I can refactor my handle inc just like this. So get state count plus 1. And the same is going to apply here. No, that's fine. We need to do this here. So get state, again, count. I'm going to reformat this. And there are still some errors. Right. There are some errors because I didn't mark the onChange to be optional. So let's do that. But when I do that, I'm getting errors within my handling. Why is that? Well, because it's optional and TypeScript is warning us that, hey, dude, this may not exist. So what we can do instead, again, I can leverage this pattern with default props. Like default props, and it's gonna be this on change. But this is implementation, it's not a type anymore. And I can do again the same pattern right here, and to use like type of default props right here. And I need to create that again, const. Let's copy this to here. So now we have no compile errors, that's good. And also let's render the root state just here, or count. So when I'm gonna click this, the uncontrolled component is handling the state, right? Inside. But this is our controlled component, and if I change the state here, it changes here. But it didn't change here. Why is that? Well, I need to render the correct state via or this get state.count. I'll check me that again. As you can see, this works, and decrement doesn't work because I didn't implement it. So let's do that right now. So I'm gonna copy paste all of this. Now I need to do -1 and -1 and just check if it works. Nice, it works. Again, this isn't very nice code, so what I can do instead, I can create a factory, like handle change, let's say, and it's gonna accept an argument of type inc or dec, like decrement, and it's gonna return a function that's gonna execute all this logic. Just like this. And now what can I do here? I can just use this factory. Again, I got all the types and IntelliSense right here. So this is increment. Let's call this increment. And this is gonna be handle change decrement right there. But there is a small issue. Now I'm just incrementing all the time. So what I need to do, I need to provide some mapping. So let's call it map. I'm gonna just copy this right here. And with that, I can use this type map. And because it's strictly type, like this type of object has two properties only, again, I can use the type provided as argument, and everything is gonna work. If I would provide some unvalid token, again, I have compile error, thanks to the TypeScript. All right, so let's move it also here, and that should be covered. Let's check it out. This works, this works, this works as well. Cool. What's next? So those two patterns, controlled and uncontrolled component, right? So let's say a designer will come next day to your desk like, hey dude, I need those buttons to be red, right? What are you gonna do? You're gonna just create new component with all this logic, just making the buttons red. No, that's bad. Instead, we can use render prop pattern or children as a function. What does I mean by that? So this is how it's gonna be used within JS6. So this is your component, which will provide those API and logic that we already implemented, and it will use children as a function, right? So this is the function, and it's gonna pass only public API to this function as a props. And with that, we will get access to these props, and then we can render, like view whatever we want, however we want to customize it, right? So let's implement that right now. Okay. So all I need to do is to copy this counter. All right. And I need to import this button that we implemented previously. And now I'm not gonna render this, but instead I'm gonna do this props children with some API which isn't defined yet. So let's define it. We need to go to props and define children as a function that's going to return some React child. And what's going to be here? So props, what do we want to expose? We want to expose the state, in our case, count. So I can write it manually, or I can leverage the already existing type of state. And I can do type intersection to join this state with some other APIs together. In our case, we want to provide increment handler and decrement handler. So let's do that right now. So this is going to be inc. And now, usually what you do, you annotate that function again, which is basically like you're doing the work twice, right? Because the handle increment already exists here, and TypeScript infers the type for you. But usually you need to write it down again. But that's bad pattern. What can you do? You can leverage the structural typing system of TypeScript, and classes are just types as well. So what I can do is leverage this information and use a feature called lookup types. So counter has some props, right? And what do we have on the props? Children, right? That's fine. But yeah, in our case, we just want to access our instance methods. In our case, for increment, handle increment. And now I can see it was automatically inferred. So if I change the implementation here, it will be automatically reflected in that prop API. So even less errors thanks to the TypeScript. And do the same, let's do the same for the decrement handler. And I'm gonna reformat this code. Like that. All right, so now children is a function, but again, TypeScript is yelling at us like, hey dude, you're not providing the good interface for us. Let's fix that. And what should be inside? Again, TypeScript IntelliSense count, decrement, increment. So let's do that. I'm gonna provide just this get state and count. Next one, I need to provide increment. I'm gonna just reference my internal handle increment, and the same for the decrement. Now that works. So, what about the view, right? We commented this code. I'm just gonna copy this into the clipboard, and let's use our new counter. So this doesn't work. Uh-oh. Why? Property children is missing. So this component exposes children as a prop or render props API. So let's do that, right? And all I need to do, let me just uncomment this and do this. And now we get those props from the counter. And what is props? Again, TypeScript will get me that information. So what I can do is the structure to count, decrement, increment. And now what I need to do to render that information and provide those handlers, like increment, decrement, and still we get some errors. Let me reformat the code. Okay, that didn't help. So where is the error? Thank you very much. And here is a t-shirt for you. Sorry, no t-shirts. Okay, let's reformat this. Let's check it out. Oh, ooh. So what did you say, red? Dude, no problem. Color. And this works. And what I can do even, like I can extract this to be a specific component, like red counter. Right? It's going to be just a function with all that code. And what I can do, I can just reference the code. So it's going to be red counter. And it's here. And let's move this back to the previous one. All right, like it's secondary. And I can like tweak the UI as I want, right? Like just don't even have to like render the thumbs up. I just want to thumbs down all the things. So this is render pattern. This is the most flexible API provided by React. So there is one more API that can be leveraged with React components, and that's called high order component. And what is high order component? It's just a factory or high order function, if you want. So what does it do? As I said, it's just a function that accepts as argument some component and returns new component with some enhanced behavior. All functional programming here, no mutations. So what we can do, we can implement some higher components, shall we? Which will like provide this counter behavior to some existing component. So first that we want to do, we're gonna define some counter wannabe component, which is gonna be a stateless component. Component, I cannot type. That's good because I have TypeScript and it will tell me immediately like, hey man, go back to school, whatever. And again, we're gonna do the same pattern with some props. And let's define our props right here. And let's say we're gonna have some color type because we wanna render this counter as a div. Okay, so I can use it right here. Oh, no IntelliSense. That means I didn't provide the props to my generic class. Now I get the IntelliSense. Perfect. And I can return just the div. Let's keep it here just one, and we're gonna tweak the class name a little bit. So it's gonna be like alert. And if color type is present, I wanna render alert of type color type. Ooh, this is ugly. And if not, I'm gonna not render anything. And something is clearly missing here. Just like that. Maybe like that. No. Alright, that's good. That's a bad idea. Let's extract it back. CSS class. So if color type is gonna be present, I'm gonna use it to render alert with this color type. Otherwise, I'm not gonna render anything. And I'm just gonna do this to provide my CSS class. Whew. Nice, I made it. All right, so this is just some class that's doing some things. But what we wanna do, because it's called counter wannabe, we wanna add this behavior from the counter that we introduced previously. So how can we do that? With the higher component, right? So it's gonna look like this. We're gonna create some new extended component, which gonna use this with counter higher function or component, and it's gonna consume this counter wannabe. And then I'm gonna just render this extended component. So now I have some errors because I didn't implement this with counter. And before we move on, what we need to do, we need to again implement those props for this counter wannabe that we did previously. So that means like count and increment and decrement, right? So how to do that? Well, we have one option to write it manually again, but that's not a good approach. We can do much better because TypeScript provides us with some meta programming within type system, which is pretty cool, but really mind-blowing if you ask me. So let's do that. So when we go back here to a component, we already see it has this prop with these children, and what we need to do is extract this type from that function. So how we can do that? We can write a conditional mapped type. What I mean by that? So let's write type. It's gonna be extract func args, and it's gonna be generic. And now the magic comes. So if t extends a function, which is gonna have some spread arguments of inferred type of A, and it's gonna return any because I'm not interested what the function returns. If this gonna be like if this is gonna match the definition, then I wanna return the inferred type A. Otherwise, I don't wanna do anything, right? So now I can create injected props via this extract arguments, and I'm gonna use my counter. Where are you? Where are you? Do, 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 do. I forget to export this count, obviously. No. So now it's here. So what's injected props? Never. Oh no, because not a function. So again, what I can use lookup types at our counter. So props, right? And what's next? Children. So what's injected props now? Ooh, we're almost there, but it's array because those spread operators are tuples. So we are interested only in first item. What? Okay. What happened? All right, we need to use the zero accessor after we extract those arguments, and now injected props is the definition that we are looking for. So let's use it here. And now I'm getting some errors because I still didn't implement the with counter. So let's do that now. So it's just a function that accepts a component, and we need to annotate this component to be component type of some props. Let's use some generics, shall we? So we're gonna constrain this generic to be type of injected props, right? Because that's what we want to inject into our component. And now what I'm missing? All right, and I need to return some new class, new component, and it's gonna be called with counter extends component, and I'm gonna return this with counter component just here. And I need to provide these props. So there are still some errors. Count is missing. Well, obviously it's missing because I didn't inject it physically in the component, and type system knows that. So what I need to do, I need to subtract those generic types. So P and injected props like this, and subtract is again some map type provided by the metaprogramming of TypeScript. And with that, the errors are gone, right? Because from a type system perspective, we are constraining those props to be injected into the initial component that's going to be enhanced. So counter wannabe is going to be subtracted of these props, and only prop that will remain from the public API perspective is this color type. And let's check it out if it really is there, and it's here, right? Well, the magic, but it doesn't render anything, so we need to finish our implementation, obviously. So we need to provide render. And now what we're gonna do, we're gonna return our component. And also we need to extract some props. So first thing we need to do is just extract some pass-through props. Pass-through, I hate this word. And we get some error because that's like a bug in the TypeScript compiler that you need to explicitly cast spread on generic objects. But hopefully it's gonna be fixed sooner than later. And now let's pass those props down to our initial component like this. And there are still some errors. Right, because that component needs those count and increment and decrement. So how we can do that? We can now re-implement all that behavior that we introduced in the render props pattern within this higher component. But wait, why should we do that? We already have our counter prop, component. So we can use that right here. And the magic happens. So again, this is gonna use this function, and we're gonna get these injected props, which are our well-known type. And now we're gonna return our enhanced component, and we're gonna spread our injected props right here. No compile errors, and let's check if it works. So here is our counter wannabe, and it doesn't do anything. So let's add this behavior here. So on click, I'm just gonna increment. And what else? Right, and I need to render the count. Oh, of course, I'm not destructuring it, obviously. Okay, there are some typing errors with on click. I forgot something. Oh, curlies. Again, TypeScript saved the day. Because I just cannot type, as you can see. And now let's check if it works. Boom, it works. And let's render it again with some color type. The color type will be success because we are successful. And what? Again, typo. And it's green. That's great. So this is like injection with higher component into some existing component that is stateless component. And there is another pattern, like we can extend even the component with new behavior. So let's define some other props. Type extended props with this max count. So now what I need to do, the inner component needs to be like joined with these new props. So I'm providing extended props. And here now I need to cast it to extended props because the TypeScript bug. And what else? Now I should be having here, right, max count. Perfect. And what I'm going to do now is, if max count gonna exist, I'm gonna check if max count is bigger. I know, like in the opposite. If count, I need to do injected props, right? Count, if this is gonna be bigger or equal than our max count, right? I'm just gonna render, stop right there. Okay, let's reformat this code. And again I have some errors, right? 3 dots. Okay, let's try to reformat this code again. All right, so those components work as before, but I have now extended behavior. So let's do this, and let's check the API. It's here, max count. So if I provide max count to be 5, this component should change the rendering pipeline after I click it 5 times. So 1, 2, 3, 4, 5. Stop right there. All right, and that's a harder component. So let's recap what we learned today. Like React is very easy. It has very small footprint. Baked by TypeScript, you get ultimate type safety and developer experience by writing user interfaces. So it's really very powerful. And we introduced those stateless, stateful components, controlled, uncontrolled components, rendered pro pattern, which is the most flexible of all of these patterns, and then higher the component. And basically, you can provide all these patterns by implementing one component to your users, and with that, your users or consumers get highly customizable APIs and can use just those that they really need in their apps. You are not restraining them to just use one particular API. So if you want to know more, definitely check my medium.com blog posts. I'm writing a lot of stuff about TypeScript, Redux, React, Angular, and stuff. And before we finish, let's remember one thing, that React is just JavaScript, right? And with JavaScript,
we can do everything that we want. Do we have a deal?
Thanks for having me, and enjoy the rest of the conference. And I guess we have 5 minutes for some questions, if there are any.
You wrote in your examples like get state, and you try to get these props, and then if the props is not defined, you try to get states. What is the state and what is the props, and why did you try to get both in one method?
Good question. So it was these 3, right? So you need to like implement this getState because you want to change like the control of the consumer component, right? So if you just render the counter like this, let me zoom it a little bit, like this, the inner state is gonna be used, right? But if you wanna control the component from the outside, you need to provide it as this prop, which is count. And in that case, you don't wanna set inner state of this component, but you just wanna call this callback that on change with these props. So that's all that is needed. That's why you need to like check if count is set. If not, then use that count as a single source of truth. Otherwise, you need to work with internal state. And all this code is gonna be like open source on my GitHub. I'm gonna tweet it as well. So if you're gonna follow me on Twitter, you're gonna have it today. But good question, thanks. Any other questions? No? 3, 2, 1. Oh no.
Can you do more of Venom, please?
Shut up.
Any more questions? Okay, so again, thanks and enjoy the rest of the conference.